Hello, everybody. Welcome back to 1342. Today, we're going to look at Chapter 3, Section 1 homework. Let's look at the first one. A defunct website listed the average annual income for Florida as $35,031. What is the role of the term average in statistics? Should another term be used in its place of average? The term average is often used in statistics to represent the mean. There's that word. They mean the same thing, but no. The term average is often used. It's not the median, actually. It's the mean. So it'd be anything. It's the mean. So A is not for sure, right? The term average is not used in statistics. The term mean should be, okay, so the term mean should be used for the result obtained by adding all the sample values and dividing by the total number of sample values. Okay, so that one, yes, it is the mean, and it's not used, so that one C is right. It's not the median, so the answer is C. Number 2, listed below are pulse rates, beats per minute for samples of adult males and females. Find the mean and median for each of the two samples, and then compare the two sets of results. Okay, so whenever we have a set of data and we're asked to analyze it, the first thing we're supposed to do is organize it in increasing order. So what I went ahead and did here is that's exactly what I did. I took all of the male, this is the data straight from the sheet, and I sorted them. Here it is from increasing order. If you're not sure how to do that, when you enter all the data, make sure first off that all your data is correct. Make sure you add up how many you have, make sure it's how many the data set has. And then with your data set, maybe I'll show you, make a copy of this over here. Highlight your data set and come over here to that, it'll say sort and filter. Increase it from smallest to largest, and watch what's going to happen. And there we go. It goes from the smallest to the largest. So that takes care of it for you. Now we could find the median, we could find the mean, the mode, and everything else. So I did that. I went ahead and did that. Now, since we're also using Excel, we could do it the old-fashioned way of add up all those. The way you do that is quick. That's where we want the answer to go, and hit that answer there. And that's only the numbers added up. All these numbers added up equal that. To find the mean, I would take this number and divide it by how many numbers we have. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So take this number and divide by 15. Or if you wanted to, you could just type in the formula for it. Equals, because it tells the computer, okay, I'm using a calculation now, and type in average. Open parenthesis. I want to take the average of this data set. And close parenthesis. And there's that answer. I do the same thing here. Equal sign, tell it's a calculation. Average, open parenthesis. Hit your arrow going up. Hold the shift button and arrow up. And then close parenthesis. And I come here to so far I one decimal place. All right, same thing for the median. Okay, I could do this old-fashioned way. Since I have 15 pieces of data, I could take 15 divided by 2, gives me 7.5. So since it's a decimal, I round it up. I go to the 8th place, and that'll get me the median. So 1, 2, 3, 4, 5, 6, 7, 8. The median of that one is 67. Or do it, let the computer do it. Equal sign, type in median, open parenthesis, and now I do the same thing with my mouse. I highlight all that range, close parenthesis, and there you have it. Equal sign, median, open parenthesis, highlight the range of your data, and there you have it. Let the computer do the work for you. So the mean for the male is 70.4, and the mean for the female is 83.9. Go back. The median for the males was 67, and the median for the females was 87. All right. Now compare the results. Choose the median is lower for males, but median is lower for females. So it means that one's not right because males are lower, both of them. The mean is lower in males, but median is lower. No, that's not right. The median and the mean for females are both lower. No. So you see they're both higher than males. The mean and median for males are both lower than females. Okay, that one right. They don't, not the same, so the answer is D. Does there appear to be a difference? The pulse rates for females appear to be higher than the pulse rates of men. That's what it looks like, yes. There does be a difference because both of the values are higher in females. Since the sample size, that's not what it asks. It asks, is there a difference from our data? Yes, there is. No. So the answer is A. All right, let's look at question number 3. And for number 3, this is the data. So use the magnitudes of the Richter scale, that's for Earth measuring earthquakes. Of the earthquakes listed in data below, find the mean and median of the data set. Is the magnitude of the earthquake measuring 7.0 on the Richter scale an outlier? Okay, is 7.0 an outlier? When considered in the context of the sample data given. All right, so let's look at this. Mean median. All right, same thing here. I went ahead and created, here's the original data set. I entered all of those. And I went ahead and sorted them. And that's what I got. And I went right here, I typed in the average equals that whole data range. I got the average. The mean is 1.621. It says round to 3 decimal places. And so that's the fourth one is a 2. I don't need it. And the median is 1.505. So the data goes from 0.08 to 2.99. Okay, now, because this is a large data set, I was going to consider using a chart. using a frequency chart like this in ranges. But you notice the average I use here, I took these, found the midpoints, multiplied by the frequencies, I got this. I added all of these, I got 80.750 divided by 50, and I got 1.615, which is just a little bit lower than the 1.621. 1.621. And that is because I'm using an estimate of the values. I'm saying that there are 5 of these numbers or 5 of these numbers in a data set. But we see from our data set, we have these numbers. So that's why this is a very rough estimate. All right, let's go back to our sheet. Second part. Is a magnitude 7.0 an outlier? Well, yeah, because remember, the data range went from 0.08 to 2.99. 7.0 is all the way out there. So yes, because it's an obvious one because it's very far away. There is an outlier. Yeah, it doesn't mean that outlier can be a maximum value. So yeah. All right, number 4. Find the mean of the data summarized in the frequency table below. Compare the computed mean to the actual mean. Remember, I said like we did last time. The computed mean was when I used the table, and I was off by just a little bit. And that's what this is going to show us. So whenever you use intervals, yes, you will have some certain amount of error. And that's what we're going to look at here. Is it valid or not? So using this table, this is question number 4. All right, so in order to find the mean of this value, I first off have to find the midpoints of each of these ranges. So what I do is I take the 2 numbers, 42 plus 45, and divide by 2. So the number in the middle of those two is 43.5. Since from 42 to 46 and from 45 to 49 is 4 numbers apart, then I know the next median is going to be 43.5 plus 4. Now, if I add 4 to each of these, like from 42 to 46, I added 4, then 4 more, then 4 more. I do the same thing with the mid numbers. So I add 4 to all the previous numbers. So it's that one plus 4. Should work there. Yep, so those are mine. So now to find, I have to multiply the mid number times the frequency. So XM times the frequency. That number times the frequency. I do it for all of those. Add them all up. And now to find the mean, I take this number and divide by how many I have. Oops. The number I have is if I add up all these. Let's see how many I have. have 50 of them. So I take that number, divide by 50, I get 46.78. So let me go back to my chart. So the mean is round to the nearest 10th. And the 10th is the first one. So remember, it's 46.78. So it's 46.8. Which of the following best describes the relationship between the computer, that mean, and the min? So what we have to do is we have the computed mean is 46.8 to the actual mean. The way you do that is find the difference between the two and divide it by the number you started off with. So it went from 46 to 51. Let's see how big of an increase it is. So back to my calculation. So the first thing I do is after doing a calculation, I do 51.5 minus 46.8 equals that. So I have 4.7. That's the difference divided by the first number, 46.8. I get 0.100. Convert that to percent. I get 10%. So it's a 10% change. It's not close because the difference between is less than, no, it's more than 5%. It's not less than 5%. The computed mean is close to the actual mean because the differences between the mean is more than 5%. No, if it's more than 5%, that's not close. It's not close because it's more than there, so it's D. All right. Now number 5. One common system of computing grade point averages, GPA, assigns 4 points for A, 3 points for B, 2 points for C, 1 for D, and 0 for Fs. So what is a GPA of a student that gets an A for a 3-hour course, a B for a 2-hour course, a C for a 3-hour course, and a D for a 4-hour course? So let's go back and look at this calculation. So like I said, for A, you get 4 points. For B, let me make it a little bigger here. A, you get 4 points, 3, B is 3, C is 2, and F is 1. So this is what the student actually got. You got A for a 3-hour course, a B for a 2-hour, a C for a 3-hour. So let's see how many points they're going to get. So for an A, it's 4 points. For B, it's 3 points. For C, it's 2 points. And for a D, it's 1 point. Now, so what we have to do is multiply the course weight times the number of points. So I'm put an equal sign there because I'm multiplying this number times this number. And I do it to all of them. So now I have to know how many points did I attempt. Since I tried these number of courses, these are the number of points I attempted. 12 points. So I take this value here, the course weight times the points I got. So the grade this person actually got, their GPA is the 28. That's this one, divided by how many they attempted. 2.33333. So it's approximately a 2.4. They'll also give them a 2.4. It's an approximate grade that they have for that course, for that semester. So it's approximately a 2.4. Now 2.4, that's a C, a solid C average. Because 3.0 is a B, 4.0 is an A. All right, the last one, number 6. Which of the following is always true? Data skewed to the right have a longer left tail than a right tail. No. A symmetric and bell-shaped distribution, mean, median, mode are the same. So far, that's right. For skewed data, the mode is further out than, no. That's a mode, that doesn't mean anything. The mean and median should be used to identify the shape of the distribution. Not to identify, no, because all three of the values are the same. So that's not always a true. Because what if they're all one? So the only one that makes sense is B. All right, everybody. Good luck and thank you much.